Guys, you know what time it is? It's time for another one of my famous pen and paper computer science tutorials. But in order to do that, we will first need some paper. That's amazing. Works every time. And my pen's right here. Okay, let's get started. Now, we're going to be talking today about reference variables. Boom. See, squiggly line makes it more official. Okay. I want to start off by saying that I'm going to introduce this using C++ syntax because that's what I know best. But the concept works the same no matter what language you're using. So let's get down to it. In programming, we have functions, and functions will have a return type. Okay. Then they'll have a name. And then they will have parameters. That shouldn't be all caps. Sorry about that. And then obviously we're going to have something that it says to do. Let's give ourselves a little room to work with. And down here it will return something that is of your return type. Just made that a little more official looking. Okay. As you know, parameters, or hopefully as you know, parameters and everything in programming has scope, which is just the degree to which variables are usable and basically how long they remain on the stack before they're removed. So this list of parameters right here has scope only within these two brackets. So anything listed right here, even when it's passed, because obviously we're going to pass something from outside the function into these parameters, we aren't passing the actual variable. So let's say we have a variable called x. We don't actually push x through the parameters and into the function. That doesn't happen. What we actually do is we pass x to the function. X goes back to where it came from, and we make a copy of it, and it's like a little copy of x, a pseudo x. And then the function is able to manipulate this variable and perform whatever operations we want to do on it. We can multiply it times something. We can, whatever it is we're doing. And then the results of whatever we do get passed to our return statement, sent back to the return, and stored into whatever function called this function. Now, when we do a reference variable, it gives us kind of a loophole, because right now we don't have any way of passing a variable through here. That's what a reference variable actually allows us to do. So what I've done is created a little function here to illustrate that. Let's say that we have a function called myFunction, and we're going to pass it a number. Well, the way this is written right now, this won't do anything. We'll pass in, let's say we have a little integer type variable over here, and we'll call it int myInt. Let's say it's equal to 5. Okay. Now, let's say we call this function. So obviously to do that, we would just, let's forget all this right now. We would say, since it's void, we're not actually going to store it to anything. We're just going to say myFunction, and we're going to say myInt. What happens when I call this? I'm passing myInt into this new parameter. We're renaming it number. Basically, we're just making a copy of the number 5, renaming it number, and now we're saying that number equals number times 2. So really we're saying this new variable we've created that we initially put the 5 into is now being multiplied by itself times 2 and stored back into itself. So now number is equal to 10. However, that's where it stops. Because it's a void, I didn't do a return statement. We don't have to. And since we just made a copy of the 5, nothing actually happened. But what we can do, we can give ourselves a little loophole, a little way to pass through the function, and that's an awful way to write that. Sorry, I'm not good at drawing those. but that's the ampersand, int and number. Basically what that means is we're turning number into a reference variable. So when we pass this 5 into it, instead of bouncing off really back to where, you know, the function caller, it actually allows this to pass through and become number. And then we go ahead and say, you know, basically number equals 5 times 2. So this becomes 10. And when the function is terminated, when it returns, you know, we can write a return statement here if we want. It just won't return anything. Bad handwriting. Number actually gets shot back up and put back into this place. That was a fun sound, wasn't it? So now number equals 10, or my int equals 10. This is how reference variables work. And the main purpose for having reference variables is when you want to have a function that returns more than one piece of data. So that's why generally your functions featuring reference variables are going to be of return type void, because you don't need to use a return statement. You just return things through the reference variables. If you want to, you can, I suppose, choose to return things this through here, through the return statement and through the reference variables. That's not really good programming practice. It's cleanest just to pass it all the reference variables it'll need and allow them to be passed back up through the function when the function terminates. Last but not least, I just wanted to clarify a little something that hopefully you already know, but this right here, the variable name, does not need to match the way the name as it's declared in the function. If you're declaring prototypes with reference variables, you could also just say we were declaring a function prototype, my function. You could just, you know, obviously wherever your header file is, or, you know, before your main function, if you're just doing a single program file, you would just write my function int and done. That would be all that you do. And then you can choose to name it later on. This name does not have to match that name. It's going to get passed through, come back out. Just make sure that you're manipulating this name right here. This is what your variable is called inside the function. So a lot of times it's personal preference whether you want the variable name here to match what it says here, because then you can kind of get confused, but at the same time you're most likely not going to need to make a distinction between number as it exists in here and my int as it exists out here. So do whatever suits you. This has been a quick tutorial on how to do reference variables, how to use them in the C++ programming language. They work exactly the same way except with different syntax in every other language. It's just a way to give your variables within a function some scope that exceeds that function. So that way when the function returns, when it ends, you're able to manipulate the values of variables that previously existed outside of the function. Hopefully that makes sense. Post questions in the comments.